Welcome back to Algebra 2. This is Semester 1, and we are going to do some compositions today with math from the Big Ideas textbook. So it looks like I'm having some pen problems again. Yep, definitely having pen problems again. But we'll see if we can move on. There we go, and see if it works. All right, so what we have here is some addition, subtraction, multiplication, and division of two linear functions. One function is 5x and the other is x plus 2. And then we also have the division. There we go, finally. So look at the division. When you take the linear function, which has a domain and range of all real values, and you divide it by another linear function with a domain and range of all real values, you would think that the domain and range would still be all real. All you did was divide, right? But the problem is you have an x plus 2 in the denominator here, and the value you're not allowed to have in the denominator is 0. So you have to figure out what value would make the denominator equal to 0. Now, a lot of you can just look at this and already know in your head that that's negative 2. But if not, what you do is you set the denominator equal to 0, and you see that you get x equals negative 2. So that means your domain here is all real x's. However, x is not allowed to be negative 2. Okay, let's move on and we'll do some examples. It says we've got our f of x is 3 times radical x. Our g of x is negative 10 times radical x. We want to find f plus g of x. So all we're doing is adding. Then we're going to state the domain and evaluate the sum when x is equal to 4. Okay, well, it's rad x, the other one is rad x, so we are allowed to combine our like terms. That's like saying 3 markers minus 10 markers. So I get negative 7 radical x. Okay, now let's state the domain of that. The domain of your f function is all of your x values that are greater than or equal to 0. The domain of your function for g is all of the x values greater than or equal to 0. We didn't have any division, so it's just x values greater than or equal to 0. Now, to evaluate the sum, you plug the 4 in. So negative 7 times the square root of 4 is equal to negative 7 times 2. Hey, that's negative 14. All right, let's try another one. So now we have these two big polynomial functions, 3x cubed minus 2x squared plus 5 and x cubed minus 3x squared plus 4x minus 2. It says find f minus g of x. Then state domain, then evaluate. Okay, since it is f minus g, the f comes first, or the f goes on the top. I'm going to see if I can get a better pen here. There we go. All right, so I have 3x cubed minus 2x squared plus 0 x's plus 5. Then for my g of x, I have x cubed minus 3x squared plus 4x minus 2. They said we were subtracting. So when I draw my line, I change my sign. So change all your signs the whole way down. Okay, so when I subtract now, I'm going to go ahead and get 2x cubed plus x squared minus 4x plus 7. Now, this is a cubic function, not a cube root function, and cubic functions have a domain of all real. So I basically have an all real minus an all real. So it is still a domain of all real numbers. Now, to evaluate this, I want you to put me on pause and plug this into your calculator. So remember, you say -2, store as x, press enter, and then enter our function exactly how you see it. So press pause and try it out. Okay, so I plugged it in here and I have a not working pen again. F, there we go, minus g of -2 equals 3. I got a 3. Did you get a 3? All right, let's try some more. It says let f be x squared and let g be the square root of x. Find the product f times g of x. State the domain, then evaluate. Okay, here we go. We're going to multiply. That is x squared times square root of x. Now, you guys all remember that that's radical form, but I can write it in exponential form by saying 1/2. Then you should also remember that means you add. So I have x to the 5/2 because 2 plus 1/2 is 5/2. All right, now let's talk domain here. An x squared function is a quadratic and its domain is all real. But a square root of x function is not. And what we know is that the domain is all of the values that are greater than or equal to 0. So what happens is we take the more restrictive domain. We look here, this is 5/2, so it also has an even root. So it also needs only positive x values. And so we say that the domain is greater than or equal to 0. All right, now they want us to evaluate. So that's 9 to the 5/2. We can do that by hand if you want, or you can put it in the calculator also. So you decide what you're going to do. I got 243. So there's our 3 answers for this problem. All right, f is 6x, g is x to the 3/4. We're going to divide and state the domain. Then we're going to evaluate. So I want to divide. They told me to put f on top, so 6x is in the numerator, g's on the bottom, so x to the 3/4 is in the denominator. And now we have to simplify this. And did you remember that when you are simplifying division, it is subtraction? So this is really 6x to the 1 minus 3/4 all over an invisible 1. Okay, look at your cheat sheet if you need to remember the rule. Talk to each other. Remember the previous lesson. And now what we're going to do is say that that is just 6x to the 1/4. Okay, that's great. Now let's talk domain. This is a linear function. It's all real. This is not. This is an even root. And even roots are restricted to all of the x values that are greater than or equal to 0. Now, this guy right here is also an even root function. So you want to say that it is greater than or equal to 0. But stop, because right here you had an x in the denominator. Well, when you have an x in the denominator, that means you might accidentally make the denominator equal to 0, which remember is a no-no. So what number could you put in the denominator to get a 0? Well, this one's easy. It's just 0. Now that means it's not allowed to be a 0 in the denominator. So my domain this time is only x's that are greater than 0. Not greater than or equal to, only greater, because you're not allowed to put a 0 down there. Okay, now we're ready to go ahead and plug the 16 in, and I'm going to do this straight in my calculator. Okay, so I had 6 times 16 to the 1/4. I put it right into my calculator, and I got 12. So I lost my pen, but the answer is 12. I'm going to stop and make a different show.